Hello, everyone, and welcome back. So in this part of this week's lesson, we're going to take the example we built in the previous video, where we created a client for the Twitter API, and we set up a stream of tweets here, and we can see them by opening the console. So we're getting Twitter to send us a bunch of tweets right now that either contain the words "I feel" or the words "I am feeling," not necessarily in that order. And those tweets are coming to an event over here. And ultimately, our goal is to get these tweets passed on to P5.js, right? Passed on to the client application over here so that we can do something with them. In this case, we're going to display them and get a computer to read them out loud. But before we can get to that point, it would be nice if we could clean them up a little bit. And this is something that you're going to run into quite a bit if you work with text data at all. Once you get your text data, you're probably going to want to manipulate it a little bit. So we're going to focus on that for this lesson, kind of cleaning up our tweets here and getting rid of elements that maybe we don't want to pass on to the client. For example, these emojis, they may be kind of funny to read out loud, but maybe we don't want them. Maybe we don't want to have retweets because that gives us a lot of duplicates in our stream here. Whenever we have retweets, we're going to get sometimes the same tweet twice, as it gets repeated. And maybe we can also talk about removing the mentions, right? The usernames, the hashtags, and the URLs, right? It's not super interesting to listen to a voice reading a URL out loud. So we're going to talk about strategies we can use to scrub text clean of the pieces we're not interested in. Okay? So the first thing we could tackle is getting rid of the retweet, because that's a fairly easy one. So in order to get rid of the retweets, one of the attributes on the tweet object here is an attribute called retweeted status. So if the tweet that we received is indeed a retweet, this field of the object is going to be set to the JSON data for the original tweet that's being retweeted. So we're seeing that being displayed over here, all this JSON data. On the other hand, if there was no tweet, if it's not a retweet, if it's an original tweet, this value is going to be equal to undefined. Okay. So what we can do here is we can say if tweet.retweeted status, right? And just put that into the if statement, which means that if it's undefined, this is going to evaluate to false. Okay. If this is undefined, it means that there is no retweeted status, which means the tweet was an original tweet. So if this, if the retweeted status is undefined, this is going to evaluate to false. If it is defined to something, whatever that is, it's going to return true here. So we can put in simply a return right there. So this is going to say get out of this function, right? If we find a tweet that has a retweeted status field set to something. If it's undefined, we're good to go, and we're going to pass this if statement. Okay, so this is going to get rid of RTA retweets. Okay. An extra E over there. All right. So if retweeted status, return. And now we can log our tweet again. And we should be able to see, I'm going to clear the console. We should no longer see any, we're going to log tweet.text, because tweet is the whole JSON object, which is a little bit overwhelming. We're just going to log the text, and now we should be able to see, we're not going to see any more retweets. Okay? So already that's a pretty good improvement on our Twitter stream. Okay. The second thing we're going to do is we're going to further refine this stream by making sure that the tweets that we do keep actually contains the iterants I feel or I am feeling, as opposed to just having these words somewhere part of the sentence. Okay? So one of the ways that we can do this is we could set up an if statement, and we could use the tweet.text. Now, actually, we're going to be using tweet.text quite a bit, and we're going to be manipulating it, kind of removing things from it. So just to make this a little shorter, let's make a dedicated variable that's going to contain the tweet.text, just so it's a little bit shorter. Okay. So we're going to call it text. And then we'll say if we're going to use the search function of the string class. Okay? Now, if we search for something in a string, we could provide a substring, let's say I feel. Okay? And if we were to search for that in a string, if it found that substring, what it's going to return is the index of the first letter in the string. Okay, so the position of that little substring inside the text is that's going to be the number we receive. Okay, if it doesn't find it, it's going to return -1. Okay, so we could say that if this is less than 0, okay, it means that the search bit here hasn't found I feel. Okay, and then we could say and text.search I am feeling. If this is also less than 0, right, if it also returns -1, what this tells us is that the text does not contain either the words I feel together like this, or the words I am feeling together, in which case maybe we'll pass on this tweet as well. So what we're trying to do here is kind of like whittle down our data to some more interesting, maybe more focused set of tweets. Okay. So this is one way that we could approach it. So now if we look at the results, we're going to only see sentences that contain like I feel, right? I feel. There's probably going to be a I am feeling eventually somewhere in there. But we are going to miss some tweets though if we do it that way. And that's because when we search like this, it is case sensitive, which means it's going to look for capital I. And if somebody wrote, which people are known to do on Twitter, with an lowercase I, even though it's not grammatically correct, this would get missed. Okay, so one way that we can work around this is figure out all the possible, combinations of capitalizations. That would be pretty unmanageable. Another option is to, we could turn this text string here to lowercase first. We can make a copy of it. Then we could search for only lowercase words in it to make sure that we don't miss anything, and then go back to our original string. That's also kind of annoying. So a better way to do this is to use something called regular expressions. Okay? So I'm going to just briefly jump over here. I'll link to this in the description. There's many resources online on regular expressions. They're not specific to JavaScript, but they are supported in JavaScript. And what regular expressions do is basically kind of a markup language where you can define patterns that are going to be used to match specific combinations of characters inside strings. Okay? And they can be very simple or very elaborate. In fact, regular expressions are pretty hard, in my opinion, at least for me, and I don't use them all that frequently. So whenever I have to use regular expression, I have to teach myself again how they work. But we'll give a couple of examples today of how we could use regular expressions to do things like search for specific patterns within a string, but also scrub and replace patterns of text and replace them with blank text so that we can remove certain things from our tweets, like @mentions, like hashtags, like URLs. We're going to use regular expressions to do that. Okay, so in JavaScript, one way that you can define regular expressions is instead of using double quotes, we're going to use forward slashes. And now the stuff we're putting in between the forward slashes is a regular expression. Now, this is a very basic one because it doesn't have any kind of special character to it. There's a lot of kind of command type characters you can add to your regular expression to make it more versatile, or maybe have some wildcards in there, or have it kind of expand, follow certain patterns. We'll give examples of that in a second. But for now, we'll start with regular expression to identify I feel and I am feeling. In order to solve the lowercase uppercase, all we can do here is at the end of our expression, we can add what's called a flag. That's going to be a letter at the end of the last forward slash. And the letter I indicates case insensitive. Okay? So it means that whatever this pattern is we're searching for, we're going to look for it, and we're not going to care about the case. So it could find it in all caps. It could find it with like a capitalized F. So just by doing so, this is going to open up the kinds of results we can get. So already we can see that we got both I feel lowercase and I feel uppercase, right? Or I feel, right? Uppercase. So now we can get all these different combinations. So that kind of gives you just a little hint into the power of regular expressions. They allow us to define basically rules that we can then use to match pieces of text. Okay. So search is one way that we can do this, right? The other thing we can do is there's a function called replace. So with replace, we can say, take a pattern, either a string or a regular expression, and when you find it, replace that pattern with another piece of text. Okay? Now, in order to explore replace, I'm going to close this node console here, and I'm going to open the regular JavaScript console, clear all of this stuff out of the way, and we'll just explore the regular expressions in the console here, and then we're going to translate that back into our program. So first, let's make a just a sample string here. Okay. So I just this is like a made-up tweet. Okay, it has an @mention at the beginning, so this is something we're trying to remove from our data. It says this tweet is about my feelings and how I feel. It has a URL. Okay, so we're going to also write a regular expression that's going to look for this type of pattern and remove them, and it has a hashtag. So we're also going to remove hashtags because just for us, it's an example. Okay, we could leave the hashtags, we could remove them, but this will show you how you could go about doing that. So now I created a variable called t here, lowercase, and that just contains my string. Okay. So what I could do with replace, for example, I could search for a word like the word tweet. I could replace it with something else, or I could replace it with an empty string. Okay. And if I do that, it's going to go and delete what it found, replace it with an empty string over here. So this leaves me with a blank space. Okay. Or more useful, in this case, we could define a regular expression. Okay. So first we're going to tackle how we would remove an @mention. Okay. So an in the world of regular expression, we can define it as, first we're going to have an ampersand character. Okay. Then that ampersand is going to be followed by any number of symbols, right? As long as they're not a space. Okay. And then we're going to keep looking through characters basically until we run into a space, and that's going to be the end of the regular expression match. Okay. So in regular expression language, we can define it like this. We're going to say start with an and, okay, an ampersand, and then the wildcard to say any character that's not a slash is \capital S. Okay, so this is like a regular expression command that says expand to any character that is not a slash. And then we're going to put a plus here. In the world of regular expression, the plus just means keep going, right? Until the rule that you just defined right before it, until this rule breaks. Okay. So this rule says anything but a space. Okay. So it's going to search for anything but a space, and it's going to keep going until it finds a space, and then that's the end of the match. So if we run this regular expression on our tweet, we can see that @someone has disappeared. It's been replaced by an empty string. Okay. So pretty neat. Now the hashtag is kind of similar, right? We could do the same thing with the hashtag. This is now deleting the hashtag from the tweet, right? Because we're looking for a tag here, a hashtag, followed by any number of non-space characters. Okay, this is what this means in regular expression. Kind of it has its own little cryptic jargon, but once you learn the different commands you can do, you can kind of dream up any type of string pattern matching that you want, and it can be really, really flexible and powerful, if only a little cryptic, like I said, and difficult to wrap your head around at first. But we can keep them simple, like these ones here, to do some basic tasks. Or we could do something like this. We could say, look for an ampersand, or the horizontal bar means or, okay, or a hashtag. Okay, put that in parentheses, so this becomes like a group. So it's going to be either that or that, followed by any number of non-space characters, and keep going until this breaks, and that's my that's my regular expression. Now this is now finding the @mention, but it's not finding the awesome tag. Okay, that's because replace is just this regular expression is only gonna find the first occurrence, right, of this pattern. If we want this to keep going and remove all of them, like let's say there's a whole bunch of mentions, we want to clear them all at once, we're going to add a flag, which is going to be a letter at the end of the last slash here. And the flag we're going to use is G for global. So when we put the G flag, it means keep going, right? So look for this pattern and then keep going, find all of them that you can find in the string. And now this regular expression now is deleting this token here at someone, deleting that token at awesome, okay? Hashtag awesome. So we can then take that back into our code here, and we're going to say, you know, scrub at mentions and hashtags. Okay, so we'll say text equals text dot replace, and then we will apply our regular expression rule here to find all of these patterns that fit that particular rule, and we're going to replace them with blank. Okay. And if we take a look at our server console, we should see that if we clear it. Oh, why am I still seeing them? That's because I need to log not the tweet.text, but our text variable we just modified. So if I open my server console again, now we'll see some tweets fly by, but you can see all the at mentions are gone, and all of the hashtags, if there were any, are gone as well. Okay, so we're cleaning up our data a little bit. So we could also apply the same logic to the URLs. Okay, the URLs are going to look a lot similar. Let's create a regular expression that's going to find URLs and then replace them with blank. And it's going to be global because if there are multiple URLs, we want to remove all of them. So what's a URL? Well, it's a piece of text that's going to start with usually either HTTP or HTTPS. Okay, we're only going to look for HTTP. We're not going to worry about other protocols. That's the bulk of them on Twitter. So it's going to start with either HTTP or HTTPS. Okay, so that's the first portion that we're trying to match. Then it's going to have a colon character, and it's going to have 2 forward slashes. Now here we can just put a forward slash because forward slash in regular expression has a meaning. It means start and end the regular expression. So we're going to put a backward slash in front of it, which means we're going to escape it. Okay, so we're going to put the backward slash. That means use the forward slash character. This is the forward slash character. And then after that, we want to match any symbol, any character that's not a space. Okay, keep going. So it could be letters, it could be numbers, it could be dots. Okay, it doesn't matter. So we're going to say \s plus, keep going. And then that's going to be our pattern match for our URL. So if we replace that into our test tweet here, we can see that the URL is gone. Okay, so pretty useful stuff. Let's scrub URLs. Bring that into our code. Cool. Okay, so I'm going to drop this console now and bring back the node console so we can see our logs. And now we shouldn't see any more URLs appearing. Okay, so what's left? There's probably more we could do to clean this up. There's emojis. So we're seeing a lot of emojis in the tweets. So that's also something we can tackle. Now the emojis we could remove using regular expressions as well, but this gets a little bit more complex because there's so many of them, and there's a lot of patterns to think of. So for that purpose, we're going to turn to a library that already does that for us. So let's go back to package.json. And let's search for a library called emoji-strip. Okay. So emoji-strip is a little Node.js JavaScript library that will take a string and then get rid of most of the emojis for you. I say most because I noticed it's not perfect, but it's good enough for our example. So let's add this library to our package file like this. Okay. Then jump back to our server. And then let's say up here, we're going to say emoji strip equals require emoji dash strip. So this says, again, take this module, right? Import it and put it into this variable. So now we can use this. This happens to be a function. So now we can say text equals emoji strip text. So it's going to take our tweet as input and it's going to return a version of it without the emojis in it. So now we should see a lot less emojis into the tweet stream down here. We might still see one or two because I did notice that happening as I was testing. I'm not sure why that's the case, but it catches most of them. Okay. So we don't have to reinvent the wheel sometimes. It pays to do a little bit of research to see if there's a library that exists in order to do a particular task. Okay. And in this case, it did. Okay. Oh, I saw one up here. This guy, it missed it. I'm not sure why. Anyway, we're not going to worry about it too much. And the last thing we're going to do, this is not totally necessary, but you may have noticed these don't line up anymore because if we removed an at mention at the beginning, it leaves us with a space. We have some extra white space in our string. So we're going to say the last cleaning step is going to be using the trim function. That's going to remove extra white space. Okay. So trim removes extra white space at the beginning and end of a string so that now they're all just going to line up a little bit more nicely. Okay. So little detail here. Remove emojis. Put a comment so remember what this does, although it's pretty self-explanatory. And now at this point, you know what we've done is we've set up right our filtered stream up here. We're getting a whole bunch of tweets from Twitter, which are restricted already with these constraints, but then we are further cleaning this up by applying constraints of our own. So first, right, we're getting rid of any retweets. Then we make sure that the tweet actually contains these words together, right, as written like so. So they're not just kind of scattered across the tweet. And then we clean up the text a little bit because we know that in our final goal here for today is going to be to get these tweets to be just spoken out loud by the text-to-speech. So we try to get them as clean as we can at this point without any kind of extra things like mentions, hashtags, URLs, things like that. And we've done that using regular expressions. Okay, just barely scratching the surface here on regular expressions, but just, you know, this is whenever you have tasks that require manipulating text, odds are there's a regular expression-based solution for what you're trying to do. So if this is interesting to you, it's worth investigating that further. Okay. So now we're at the point where, you know, we have some pretty decent clean tweets being generated here from the Twitter API. So for the last phase of this week's tutorial, we're going to talk about how we would get this data, these tweets, back into the client, right? Back to P5.js, which lives over here. Now, unlike last week where we had P5.js initiating the conversation by using routes on the server, here we want to push that information to the client as it comes in. We have the streaming data. We want to stream it back to the client. We're going to see one strategy how we can do that in the next video. So I'll see you there.